Okay, method two for simplifying complex fractions involves using the least common denominator, okay, of all fractions within the complex fraction. Now, this can be sometimes an easy method, sometimes it can be a little lengthy, and what's key here is if you're going to use this, you need to understand it. It can be very, very quick if you understand it. I'm going to take some time to write everything out, so it's not going to seem as efficient, but if you practice with it a couple times, it is a very efficient method if you understand it. Okay, first thing I'm going to do is we need to look at every single fraction in this expression. So all four of them there, and we say, okay, what's the least common denominator between all of them? Well, to answer that, you need to make sure that you understand that x squared minus 1 will factor to x plus 1, x minus 1. Okay, that's key. So if I look for the least common denominator in all of those, it would be x plus 2, x minus 1, x plus 1. Okay, now what I'm going to do in this method is multiply both the numerator and the denominator, or the top and the bottom of the complex fraction, by the least common denominator. And what that does is it eliminates all these extra fractions in this problem in one step. Okay, can be confusing. Okay, but and I'm going to go ahead and keep with the green and blue. So I have my 1 over x plus 2 here, plus 3 over x minus 1, all over 2. Oops, let me go blue here. 2 over x plus 1, x minus 1, plus 1 over x plus 1. Okay, there's going to be a lot of writing here, but normally you wouldn't have to do that if you understand this method. Okay, now, what you have to understand is we're going to multiply our least common denominator, to the numerator. And when I do, I've got to distribute it to the tops of these fractions. So, what I'm going to end up with here is x plus 2 times x minus 1 times x plus 1. That's all multiplied to that 1 over x plus 2. Okay? Then I have to multiply the same thing. Oops, here's our plus. Multiply that same thing, x plus 2, x plus 1, x minus 1. That's all going to be multiplied to the 3 over x minus 1. Alright? All of that is over the same thing happening on the bottom. And when we distribute it on the bottom, it still goes to the numerators of those fractions. So we get x plus 2 times x minus 1 times x plus 1, okay, times 2 all over x plus 1, x minus 1, plus, same thing again, this is our least common denominator we're using to eliminate fractions. And again, it looks like a big mess here, and if you were using this method, you probably wouldn't write out this step, but just so you can see it. Okay, so we got this whole thing now. Now look at that. Now here's what's key. Okay, and hopefully you can see that. I'm going to go ahead and select this and make it all one color now that you've kind of associated what's going on there. I'm going to make it all one color, and I don't know why I didn't change that green. It's nice, but whatever. Now that we do this, now we got to look at how this thing simplifies. Okay? So you have an x plus 2 here and x plus 2. Those will cancel. You have an x minus 1 and x minus 1. Those will cancel. And we can only look at each individual fraction for canceling here. No cross-canceling or anything like that. You can't do it anyway. We have an x plus 1 and an x minus 1 down here that cancel, and an x plus 1 and an x plus 1 that'll cancel. So after all that carnage, here's what's left. And you'll notice we won't have fractions within fractions anymore. We have an x minus 1 and an x plus 1. Okay? Plus 3 times x plus 2 times x plus 1. That's all that was left up top. On the bottom, we're left with a 2 and an x plus 2 here, so we get 2 times x plus 2 plus an x plus 2 times an x minus 1. And that's it. Okay? Now, that is what we're left with after we cancel all of that stuff out. And that's the point of this method too, is that when you distribute it, you got to look at what would cancel out, and you'll essentially eliminate all the denominators of all the fractions. Be left with something like this, which is not a complex fraction. Okay? What you still have to do here, though, is we need to simplify this. So we're going to need to multiply this all out. Okay? I'm going to kind of shortcut it here. If you need to pause and try to take a look at where I'm coming up with these numbers, you know, just multiply them out. So I'm just multiplying the top out right now. We'll end up simplifying here in a minute. X squared plus x minus 2. Alright. So that's what we're left with. Okay, now let's go ahead and simplify this. I get 4x squared plus 9x plus 5 on the top. All of that over an x squared plus 3x plus 2 on the bottom. Now, if you look back at method 1 when we did this, you don't have, this obviously isn't the same answer currently. Well, that's because actually this will simplify even more, and we need to, so we'll need to factor this here. The top will factor to 4x plus 5 times x plus 1, and the bottom here will factor to x plus 2, x plus 1. Okay? And because of those x plus 1 common factors now, these will cancel. And we're left with 4x plus 5 all over x plus 2, where x cannot equal, from the very beginning, negative 2 or plus or minus 1. Okay? But this is our final answer here, which should match our method 1 answer. And it does. Okay? Now, one last thing before we go. I just want to draw your attention back to this step right here. Okay? It's a chance for us to address a common error place. A lot of students here will cancel things out. It's important that you, like, they'll see this and this. Problem is, although those are factors of terms, they're not factors of the entire numerator. X plus 2 is not multiplied to the entire denominator, or well, the entire numerator. It's only multiplied to this term right here. Okay? So it's important for you to realize that you couldn't cancel that out because it is just a factor of a term, not a factor of the entire numerator. Okay? Same with the x minus 1. The x minus 1 here and here, those are only factors of terms, not factors of the entire numerator and denominator. Okay? So just keep that in mind. It's worth taking a look at. And that's it for method 2 and rational expressions altogether.